All right, so time for our fifth video in the series. We're going to be skipping ahead to checkpoint number 7, factoring. Now, a note in this video, it's not going to be covering special cases like difference of two squares. So we're just going to be factoring trinomials. All right, so let's look at example number 1. It is x squared minus 6x minus 27. So the first thing we need to do is check for a GCF. So remember, the coefficient here is 1. So do we have a common factor between 1, 6, and 27 other than 1? No, we do not. So now we're going to set up the familiar boxes and the x next to it. Now remember, we put the first term in the lower left-hand corner, so x squared. The third term, including the negative sign, in the top right, negative 27. And then at the top of the x, we write the product of negative 27 and x squared, which is negative 27x squared. And now remember, at the bottom of the x, we write the middle term, in this case, negative 6x. So we need to come up with two numbers that multiply to be negative 27x squared and add up to negative 6x. So we have a negative product, which means we're going to have one negative number and one positive number. And since our sum is negative, the negative number will have the larger absolute value. And in this case, I believe the two that work are going to be negative 9x and 3x. So those will be the numbers we write here and here. And now we break down x squared, as always, into x and x. X times x is x squared. And then the number I multiply x by to get negative 9x is negative 9. And the number I multiply x by to get positive 3x is positive 3. And so now I can write the factored form right from the bottom up. X minus 9 times the bottom x plus 3. All right, so let's move on to example number 2. We have 15v squared plus 18v minus 24. So remember, the first thing we want to do is check for a GCF. And in this case, there is a number that goes into 15, 18, and 24. And the largest number that goes into all three is 3. So we're going to factor out the GCF. So we're going to write 3 on the outside. And now 3 times 5v squared would give me 15v squared. 3 times 6v would give me 18v. And 3 times negative 8 would give me negative 24. And now we're going to use the box and the x with this trinomial. So we're going to have the boxes here. 5v squared in the lower left, negative 8 in the top right. The top of the x is going to be negative 8 times 5v squared, so that's negative 40v squared. And the bottom, make sure to use this middle term, is 6v. So again, we have a negative product, So we're going to have one negative number and one positive number. Our sum is positive, so our positive number is going to have the larger absolute value. And the numbers that end up working here are negative 4v and 10v. So I'm going to write those two here and here. And now we have to break down the 5v squared. I see 10v over here. I know that 5v is going to go into that. So I'm going to write the 5v over here, which means I write the v down at the bottom because 5v times v will give me 5v squared. Now what times v is going to give me negative 4v? Negative 4. What times 5v is going to give me 10v? Positive 2. 2 times 5v is 10v plus 2. So now when we write our final factored form, we have to be careful to include the GCF. So we're going to write 3 and then 5v minus 4 and then v plus 2. Okay. So now we're going to move on to our third example. And our third example is 9b squared plus 39b plus 40. So we've got some fairly large coefficients here, so hopefully we have a GCF. But in this case, well, 3 is going to go into 9 and 39, but 3 doesn't go into 40. And in fact, there is no GCF. So we're just stuck with going straight to the boxes. I'm going to write 9b squared and 40, and our numbers are going to be fairly large, unfortunately. So 9b squared times 40 is 360b squared. And then the middle term goes in the bottom, 39b. And now we got to think of two numbers that multiply to be 360b squared and add up to 39b. Wow. Well, this is a little bit tougher than the other two, coming up with those numbers. So we're going to have to list some factors of 360. So of course we're going to have 1 times 360. 1 plus 360 is 361. That's way too big. 2 and 180. 2 plus 180 is 182. Still too big. 3 times 120, that's going to give me a sum of 123, still too big. 4 times 90 is going to give me 94 as a sum, still too big. 5 goes into 360. Going to check on my calculator. 72 times. 5 plus 72 is 77. Still too big. 6 also goes into 360. And it goes in 60 times. 6 plus 60 is 66. Still too big. But notice our sums are getting smaller and smaller, so we're getting closer to that 39 that we want. 7 is not a factor of 360. I'm going to check if 8 is a factor. 360 divided by 8 gives me 45. So 8 times 45 is 360. 8 plus 45 is 53. So we're getting closer. I know that 9 goes in. 40 times. But that still gives me a sum of 49, so still too big. 10 goes in 36 times. We're getting closer, but we're still too big, 46. I don't believe 11 is a factor of 360, so we'll skip that one. What about 12? 360 divided by 12 gives me 30. So 12 times 30 is 360. 12 plus 30 is 42. So we're getting really close, but still too big. Does 13 go into 360? 360 divided by 13 gives me a decimal, so not a factor. What about 14? 360 divided by 14 is a decimal, so not a factor. What about 360 divided by 15? Gives me 24. So 15 times 24 is 360, and 15 plus 24 is, ta-da, 39. So 15b and 24b are the numbers that I'm going to write. All right. So I want to split up the 9b squared. I know that 3 goes into 15 and also 3 goes into 24. So I'm going to split this up as 3b and 3b. And then 3b times 5 will give me 15b. And 3b times 8 will give me 24b. So I finally found the two factors, 3b plus 5 and 3b plus 8. Notice that neither of these binomials have a common factor, so yes, this is fully factored and our final answer. All right, so see you back for checkpoint 8.